Okay, so the next question that we have is question number 12, which is find the equation of a line that cuts off equal intercepts on the coordinate axis and passes through the point 2, 0. So the line basically passes through the point 2, 3, and it cuts off equal intercepts and cuts off equal intercepts on the coordinate axis. On the coordinate axis. Okay, so basically to find the equation of this line, in the previous video I suppose we derived the formula from x minus x1 is equal to m times y minus y1. We did derive this formula, which was x over a plus y over b is equal to 1. And this one, basically, in this formula, a is your x-intercept, b is your y-intercept, and that's basically the formula. Now, if you already know one point on the line, you can so you will be able to, eventually you will be able to get two equations and then somehow use them in order to find out the other missing values that you have. Meaning that if the line cuts off equal intercepts on the coordinate axis, that means that these two values are the same. Meaning that a is equal to b, so I can write, for example, in this formula, I can write x over a plus y over a is equal to 1, and that means that x plus y over a is equal to 1, or you can say that x plus y is equal to a. That's one formula that you could get, or one relationship between x, y, and, for example, a or x-intercept. And by the same logic, you can write x over b plus y over b is equal to 1, in which case you would get x plus y is equal to b. So then this is basically one relationship. Either of them you could use somewhere in the formula that we are going to get. And moreover, we said that basically the line goes through this point 2, 3. So if I use this equation over here, I can write x minus 2 is equal to m times probably y minus 3, and you know that your m over here is equal to y2 minus y1 over x2 minus x1. So I use one of these basically, either basically, for example, I know that I could use, for example, x1 comma y1. I could use this point over here 2 comma 3, and so my m is equal to basically y2 minus y1, which is equal to 3, and and x2 minus 2 over here, x2 minus 2 over here. And of course you know that and of course then I can take this equation over here and write it as x minus 2 is equal to basically y2 minus 3 over x2 minus 2 times y minus 3 or let me, or this is now a lot of trouble, because you have to basically somehow eliminate one of these y's or x's and so on. So let's do it in a different way. I just got another way of solving this problem. So what you can do is that since the line cuts off equal intercepts on the coordinate axes, that means that see over here, if I do if I draw the graph of this line, so 2 comma 3 is basically 1 2 and 3, 1 2 and 3, and so one point would be this is the point 2 comma 3, which happens to be on the line. Now if the line cuts off equal intercepts on the coordinate axes, it could be this way, meaning that, I mean, the only way that this line can so one possible answer would be 12. So one possible answer would be that the line has a negative basically negative slope, and the line basically is something like this, for example. This is just approximation, but supposing that, for example, this distance over here, supposing that this distance is the same as this distance. Of course, there are other configurations as well. You could probably do it this way or some other way as well. But supposing that these are, if I take this distance a, this is also a, and that's the same thing that's been said over here, that cuts off equal intercepts on the coordinate axis. Now if in this configuration your line is cutting equal intercepts on the coordinate axis, that means that basically your rise over run, your rise is the same as your run. And we said that basically the slope of a line, which is equal to tan of theta, is equal to basically y2 minus y1 over x2 minus x1, which basically, and this part over here, the numerator, is the change in y, and this part over here is change in x, meaning that how much change you have in your y, and this is how much change you have in your x. And they call this also basically rise. They call this also rise because this is vertical change, and they call this run because this is horizontal change. You're along this axis you're running, along this axis you're rising. But as you can see, since your rise is equal to your run, whatever number you have basically in the numerator, for example, let's say you have a 3, you have the same number in the denominator, but of course for the same amount of run, you have the same amount of rise in the negative direction, so you have a negative sign over here as well. So then these two numbers, whatever they might be, they will cancel out, and then you will be left with a -1. Of course, like I said, that's only one possible configuration. There might actually be some other possible configuration as well. I'm not talking about that right now. That would require you to basically use some equations. Otherwise, this way you can, the best that you could do is probably find this configuration only. So now I can safely assume that the slope of this line is -1. Based on this, I can safely assume that the slope of this line is -1. So if my slope is equal to -1, and if the line goes through this point, then I can say y minus y1 is equal to m times x minus x1. And so I can write y minus 3 is equal to -1 times x minus 2. And so y minus 3 is equal to -x plus 2. And so I can say that x plus y minus 5 is equal to 0. Or x plus y is equal to 5. I suppose that's the equation of the line, if I'm not mistaken. Number 12, x plus y is equal to, that is the right answer. And since in the book there is only this answer, only this answer has been given, based on that, this must be the only possible answer. So that's basically how you can solve this problem, for example. Question number 13 is find equation of the line passing through the point 2, 2, and cutting off intercepts on the axis whose sum is 9. And cutting off intercepts on the axis whose sum is 9. That means that your x-intercept plus your y-intercept is equal to 9. That means that a plus b is equal to 9. Okay, so let's see if we can somehow get that equation. So if we have basically x divided by a plus y divided by b is equal to 1, and if I write basically let me see, if I write a times b, and over here I can write bx plus ay is equal to 1. Okay, so I did have to take a look at the solution, but it seems that the solution is actually pretty simple. Meaning that basically you have the equation over here, x over a plus y over b is equal to 1. And of course, if you know that the sum of the two intercepts is 9, of course, then you can say that, for example, a is equal to 9 minus b, or you can say that b is equal to 9 minus a. Both would be correct. And you know, one point you already know that this point is underlined, so you can say that, for example, your x is equal to 2, your y is equal to 2. So you can write 2 over, for example, and I write a as 9 minus b. 9 minus b plus y is equal to 2 over b is equal to 1, and this way you can find your b. And so this way you will get a second degree equation, meaning that you can write 9 minus b times b, and then that is 2b plus 2 times 9 minus b, and that is equal to 1. That means that 2b plus 18 minus 2b is equal to 9b minus b squared. Minus b squared. I take everything to the one side of the equation and get basically 2b minus 2b. I can cancel out. And so 9b minus b squared minus 18. So 9b minus b squared minus 18 is equal to 0. Or I can say minus negative b squared plus 9b negative 8 minus 18 is equal to 0. Or I can say basically b squared minus 9b plus 18 is equal to 0. And so 2 times 9 is equal to 18. Or 3 times 6 is equal to 18. So I write this as b squared minus 3b minus 6b plus 18 is equal to 0. And so b times b minus 3 negative 6 times b minus 3 is equal to 0. And so b minus 6 over b minus times b minus 3 is equal to 0. So that means that your b is, that means that either b minus 6 is equal to 0 or b minus 3 is equal to 0. Over here b is equal to 6 or b is equal to 3. So this is your solution set for b. Now if you come back to the equation over here, we said that basically we said that x over a plus y over b is equal to 1, and this point was already on the line. So I can set, now if b is equal to 6, for example, then you get x over, basically, instead of x I can write 2 over a plus, again, y is equal to 2, so 2 over b is equal to 6 is equal to 1. So that means that 6a and then 12 plus 2a is equal to 1. So that means that 12 plus 2a is equal to 6a, or 12 is equal to 6a minus 2a, and 12 is equal to 4a, and so a is equal to 3. So that means that if b is equal to 6, a is equal to 3, and also if b is equal to 3, you see how algebra works for you in many magical and mysterious ways. So if b is equal to 3, again the same equation, 2 over a plus 2 over b is equal to 1. So 2 over a plus 2 over 3 is equal to 1. So you have, so you have basically 3a over here, and 3 times is equal to 6 plus 2a is equal to 1, and 6 plus 2a is equal to 3a. So 6 is equal to a. So then that means that if b is equal to 3, a is equal to 6. You see that the sum of these two is 9, the sum of these two is 9. So what you can do is that you can write, you will get two possible equations for this line, meaning that either x divided by x divided, if basically your a is equal to 3, so x divided by 3 plus y divided by 6 is equal to 1. That's one equation that you can write for this line. And of course, this one as well. That means that x divided by 6 plus y divided by 3 is equal to 1. That is also possible. And you can try to visualize this line as well, meaning that, for example, when you write x divided by 3 plus y divided by 6 is equal to 1, what that means is that this line is actually a line whose basically x-intercept is 3, so 1, 2, 3, and your y-intercept is 6, and so the line would be something like this. This line is a straight line whose x-intercept is 6, and your y-intercept is 3, so you would get something like this. Both have negative slopes, but the slope of this line is a larger negative number. So, and you can always, of course, use, for example, Desmos.com. It's a great graphing calculator. It seems that I have no internet right now. It's back. So you can start graphing, for example, over here, x over 3 plus y over 6, x over 3 plus y over 6, is equal to 1, for example. And you can see that the line, your y-intercept is 6, your x-intercept is 3, and that is basically the line that you have. Or you can make changes here, x over 6, for example, y over 3, and you see that the slope of your line changes. So basically that's how you, for example, solve this problem. Now the next thing that we have is question number 14. It says that find the equation of the line through the point 0, 2, making an angle 2 pi by 3 with the positive x-axis. Also find the equation of the line parallel to it crossing the y-axis at a distance of 2 units below the origin. Okay, so this is also a good question. So first, find the equation of the line through the point 0, 2, making an angle of 2 pi by 3 with the positive x-axis. With the positive x-axis. Okay, so based on this angle, this is a pi by 3 is basically 60 degrees. 2 pi by 3 is 120 degrees. And in case you have forgotten how to convert these angles from radian to degrees and back and forth, so you know that 180 degrees is equal to pi radians. 180 degrees is equal to pi radians. And so what that means is that if you want to, now if I divide both sides of this equation by 180, I'll get 1 degree is equal to pi by 180 radians. And if I divide both sides of this equation by pi, I will get 180 divided by pi degrees is the same thing as 1 radian. So 1 radian is the same as 180 divided by pi degrees, and 1 degree is the same as pi divided by 180 radians, and both of these are based on the relationship between, for example, 180 degrees and pi radians. You already know this. Now if you have 2 pi by 3 radians, so 1 radian is equal to 180 by pi degrees. So that means that 2 pi by 3 radians is 2 pi by 3 times this in degrees. 2 pi by 3 times 180 by pi in degrees, and then pi and pi you can cancel, and this is 60, and 2 times 6 is equal to 120 degrees. That's how you that's how you convert these angles. But so anyway, if you then want to basically, so then based on this you can say that tan of 2 pi by 3 is the same thing as tan of 120 degrees. And to get the tan of 120 degrees is the best way is to use a formula, because it's a tan function. Otherwise you could write this as, for example, sine 120 by cos 120 degrees. And that way, of course, you could use the unit circle to figure that out too. you don't need you don't really need any formulas for that. So if this is a unit circle and sine 120 degrees is equal to 90 plus 30. So suppose that you have a 30-degree angle over here, and so this angle would be 120 degrees. Now if that's the case, and you're looking for the sine of this angle. Let me do it properly so you can see what I'm talking about. So if I have this unit circle, and if I did draw an actual circle over here, and go select border, so then 120 degrees, let's suppose that, for example, this is a 30-degree angle, so this angle would be 120 degrees because it's 90 plus 30, it's 120. Now the sine of this angle is basically this length over here. It's basically this length on the unit circle. This length is the sine of 120 degrees. Because basically, because in the unit circle, all of these lengths basically from this point going all the way up to here, and from this point going all the way up to here, these are the values of the sine function, and it goes from 0 to 1 and 0 to negative 1, of course. So this length over here is the sine of 120 degrees, and any angle that you might have over here, that angle, the sine and cos ratios of that angle could be expressed in terms of some angle in the first quadrant, because basically that's how the unit circle is actually constructed. It's actually the unit circle is actually an extension of a simple right triangle over here. Or let me do it. So if you have, for example, this triangle, if I have this triangle over here, so this is your theta, and this theta you could move it all just over here, and you could have the same triangle just transported to the first quadrant. And then all of the angles that you get over here, they would construct a triangle whose sine and cos ratios and other trigonometric ratios are the same as some angle in the first quadrant, but basically you would just have to basically change the signs. For example, sometimes the angle that you have over here is positive, the angle that you have in other quadrants, that the trigonometric ratios are negative, sometimes are the same. It depends on the situation, and based on that we have all of these many different trigonometric ratios that you can use in order to convert angles from, for example, from the fourth quadrant to the first quadrant, from the fourth quadrant to the second, and so on and so forth. But if you understand the circle over here, that it's very easy to find the of course time consuming to find the trigonometric ratios of any angle. And I'm not very fond of memorizing basically formulas, and I really cannot do that really well, so I have to find a way to learn these things so that I can do them on my own without the help of formulas, preferably. So So what that means is that now, for example, you can see that this angle over here, this height over here is the sine of this angle, this angle over here, which is 120 degrees. Now and of course you don't really know what the sine of 120 degrees is, because you know the sine, the trigonometric ratios of 0, for example 30 and 60 and for example 45 and probably only 90. So these are the things that we usually know. Otherwise, other than that, then you have to somehow convert. So in order to convert this angle to some angle in the first quadrant, what you need to do, you need to find some angle whose sine is the same exact value. So if I draw a triangle over here, you can see that this triangle, of course, from the figure you can tell that this angle is already 30 degrees. So this angle is 60 degrees. So now this basically this value is of course the same as the sine of 60 degrees. So I can say that sine of 120 degrees is the same as sine of 60 degrees. And I know the sine of 60 degrees is equal to square root of 3 by 2. So that means that basically the sine of 120 degrees is also square root of 3 by 2. So that's basically how you would find, for example, something like this on a unit circle. And of course, so this is square root of 3 by 2. And then there is only the cos of 120 degrees, which we can find in the same way, meaning that we can basically, the cos of 120 degrees is basically this length over here. This length is basically the cos of 120 degrees, which is some negative value. And you can see that even using the same triangle, you can find the cos of, you can say that, so this value over here is equal to cos of 60 degrees. And you see that this is a positive value, this is a negative value. So you can say that the cos of 120 degrees is equal to negative cos of 60 degrees. Now cos of 60 degrees is 1 by 2. So that's negative 1 by 2. So that means that the cos of 120 degrees, that means that the cos of 120 degrees is equal to negative 1 by 2. So, and that means that basically negative 1 by 2 and square root of 3 by 2, and then you will see that the tan of 2 pi by 3 or 120 degrees is equal to negative square root of 3. Now if you use a calculator over here and set this to radian, and if I write tan of 2 pi, tan of 2 pi by 3, I will get negative square root of 3, which is exactly what we found over here. And of course there is other ways of doing the same thing, meaning that if you don't want to use the unit circle, you can always use the formulas that you would find in any basic trigonometry course. Meaning that, for example, to find the tan of 120 degrees, what you can do is that you can, first there is all of these formulas, for example, tan of, for example, alpha plus beta. Now tan of alpha plus beta is, for example, tan alpha plus tan beta over 1 minus tan alpha tan beta. But the problem with this formula is that, for example, if I write tan of 120 degrees, if I write it as tan of, for example, tan of, for example, 690 plus 30, I couldn't use this formula because tan is not defined at 90 degrees. It's not defined at 90 degrees. So I could probably use, for example, tan of 60 degrees, and then I would write this as tan of 60 degrees plus 60 degrees, and then I could use the same formula and write tan of 60 degrees plus tan of 60 degrees. And of course, there is another formula for tan 2x or something like that. And then over here you can tan of 60 degrees, tan of 60 degrees. And then what that is that basically you can write this as tan 60 degrees is tan 60 degrees is equal to sine 60 degrees by cos 60 degrees, which is equal to square root of 3 by 2, and cos 60 degrees is equal to 1 by 2, so that's equal to square root of 3. So over here you have square root of 3 plus the square root of 3 over 1 minus square root of 3 times square root of 3, and that's equal to 2 times square root of 3, 1 minus 2 times square root of 3. And I suppose you could write this as, for example, 1 minus 2 times square root of 3 over 1 times 1 plus 2 times square root of 3, and then you can write this as 2 times square root of 3 times 1 plus 2 times square root of 3, and then you can write this as basically 2 times square root of 3 plus 2 times square root of 3 whole squared, and that is 1 squared minus 2 times square root of 3 whole squared, and that is equal to 2 times square root of 3 plus 4 times is equal to 12, and that is 1 minus basically 12. So that is equal to 2 times square root of 3 plus 12 over negative 11, which is not really helpful, but I suppose that is actually the same value as we had before, meaning that this value over here, if you actually we found tan of 2 pi by 3 as negative square root of 3. So now if I give this expression to my calculator, I'll get 2 times square root of 3 over 1 minus 2 times square root of 3 No, I made a mistake over here, I'm sorry. I have made a mistake over here, and what that is that basically this is This is square root of 3 whole squared. This is the square root of 3 whole squared. So that is equal to 2 times square root of 3 over 1 minus square root of 3 whole squared is equal to 3. So that's 2 square root of 3 over negative 2. So these two cancel out, and then you'll get negative square root of 3, the exact same value that you got over here. So you can use all of these formulas as well, but eventually tan of, for example, 2 pi by 3 is equal to negative square root of 3. So now you can use the information that you have to write the equation of your line. And what that is that basically now you know that your m, your slope of the line, is negative square root of 3, and the line goes through this point over here, 0, 2. So if the line goes through this point, I can say y minus y1 is equal to m times x minus x1. So y minus 2 is equal to negative square root of 3 times x minus 0. So y minus 2 is equal to negative square root of 3 times x. And square root of 3 times x plus y is equal to, or minus 2 is equal to 0. That is the equation of the line. So you have square root of 3 times x plus y minus 2 is equal to 0. And that is the first part of this question, number 14. Square root of 3 times x plus y minus 2 is equal to 0. Now the second part of this question is basically you want to find you want to find the equation of the line. Find the equation of the line. Equation of the line parallel to 1. Call this number 1. Parallel to 1 and crossing the x-axis. And crossing the x-axis at a distance of 2 units, at a distance of 2 units below the origin. So crossing the y-axis at distance of 2 units below the origin, that means that your y-intercept is equal to negative 2. Okay, so now since that is the case, and the line is parallel to this line, so meaning that they have the same slopes. So now if you can find the slope of this line, then you will have the slope and the intercept, and then you can use the slope intercept form of the equation of a line to find the equation of the new line. So in order to find the slope of this line, so number 1, so you have basically when we write y, basically when we write, for example, y is equal to mx plus c, m is the slope of this line. So if I can write this equation in this form, based on that I can recognize my slope and then use it in the second equation. So I can write square root of 3 times x plus y is equal minus 2 is equal to 0. And so y is equal to negative square root of 3 times x plus 2. And so as you can see now, this is y is equal to mx plus c. And so over here, m is equal to negative square root of 3 as we calculated before. So now I know that basically the y-intercept of the line is negative 2 and the slope of the line is negative square root of 3. Now using these two pieces of information, I can calculate I can find the equation of the line. So basically to do that, we said that y minus y1 is equal to m times x minus x1. So if basically since that is the case, since that is the case, I know the y-intercept, meaning that, for example, suppose that you have a line over here that goes through the y-axis at some point, and this point is, if I call it, for example, b, 0 comma b, and of course I know the slope of the line as well. The slope of the line is m. So if I have y minus y1 is equal to m times x minus x1, now over here I have one point here which is 0 comma b and the slope of the line. So I can write y minus b is equal to m times x minus 0. That means that y minus b is equal to mx, or y is equal to mx plus b. Right? So then I can simply put the y-intercept over here and put the slope of the line over here, and then I will have the slope of the line I'm looking for. So y is equal to mx plus b. So what I'm going to do is that, based on the information that I have, then y is equal to basically m, which is negative square root of 3 times x, negative square root of 3 times x, plus b, which is equal to negative 2. And that is the equation of the line that you are looking for. So number 14 is square root of 3 plus y plus 2 is equal to 0. They have written it in this way. Square root of 3 times x plus y plus 2 is equal to 0, which is basically the exact same equation. So that was question number 14. We still have a few questions to go, like 15 to 20, which is 6 questions. So I think we will do that in the next video. See you in the next video.